going on at this point in time with school for the remainder of the school year. So at this point, we're just going to go as scheduled with the piece of paper that I passed out to you. So 6.3, performing functions in their function operations and their compositions is where we are starting today. So let me get that written down here. So 6.3, perform function operations and compositions. Now, I'm not sure that you've seen anything like this to this point, but this is very critical moving forward that you're able to do stuff like this with composition of functions. I can think of numerous ways that we use this in pre-calculus as well as calculus. So please make sure you pay attention to this section and let me know if you have any questions about anything as you go through the homework and stuff. So we're going to first look at the key concepts, and they are on page 428, but I do want to take a minute and write them out so you see what that looks like here before we go too far. So, operations of functions. Get a marker that's working a little better. Alright, so with this we start out with let f and g be any two functions. Okay, so they're not numbers, they're functions. And just as a reminder, sometimes I write functions f and ct like that. So if you see that moving forward, that's what that means. A new function h can be defined by performing any of the four basic operations on f and g. Okay, so by that we mean adding, subtracting, multiplying, and dividing of functions. So the book gives you examples. I'm just going to list out the operation and our definition. So the operation and definition. Okay, so remember definition, sometimes I list as DEF and then a little N underlined. Okay, that's kind of a common way that you'll see people do that in math, just to make life a little easier when you're writing and stuff. Also, I did get a new microphone, so if it's a little louder than your last video, that's why. You might have to turn it down a little bit. I can't really hear the volume while I'm recording the video, so if it's really loud, sorry about that. Just make sure you adjust your volume a little bit going forward. Alright, so first operation is addition. And with that we have h of x. Okay, so this is just going to be another function. Okay, that's what we call, well, sort of a composition function, but you'll actually see what a composition function looks like in a minute. So h of x is equal to f of x plus g of x. I guess the better way to refer to h of x would be the resulting function when you're adding two functions together. So addition, then we have subtraction. So for this one we have h of x is equal to f of x minus g of x. We have multiplication. If I can fit it all in that line there. H of x is equal to f of x times g of x. And next we have division, which is h of x equal to f of x over g of x. There. Okay, and there's definitions in your book there if you want to see exactly what this looks like with numbers and stuff. You can do that, but I'm going to wait and spend more time with examples on actually doing homework problems for you rather than just listing stuff that's in your book. And then the other thing that's written underneath here that's important is that the domain of H, okay, meaning the X value inputs. Okay, I know we haven't done a whole lot with domain, and that's something we'll hit more on next year. But the domain of H consists of the X values that are in the domains of both F and G. Additionally, the domain of the quotient does not include X values for which G of X is equal to 0. Okay, so essentially, can't divide by 0. That's all that means. Let's see, the book also gives a definition of a power function, which basically is just something that, so a power function basically takes the form y is equal to ax to the b, okay, and b can be any rational number, a is any real number, okay, so you might see b could be a b is a rational number, meaning it could be whole or a fraction. Okay, a is just any real number, could just be 1. Okay, so your book gives several examples there going through with different values for x, different values, f of x and g of x, with x being like raised to a fraction, x being raised to a whole number, not being raised to anything, okay, things like that. We're going to obviously be ignoring the word problem, so you can kind of just skip through those right now as you're doing the problems. And I'm not real worried about the domains of functions. Okay, going forward, I don't think any of the problems necessarily say anything about the domain, but one set of problems does, but that's it. And we'll get to that in just a minute and what that looks like. So we'll go through a couple examples, and then I'll go through the one other type of function here. So this dealing with the function operations here. So we'll do the problems going with that, and then we'll go back to the composition of functions after that. So looking at some problems, essentially here we are going to be doing stuff like 3 through 37. So I'm going to pick a couple even ones for you to do. So let's see here. So we're told in the instructions that we're to let f of x be equal to negative 3x to the 1/3 plus 4x to the 1/2, and g of x is 5x to the 1/3 plus 4x to the 1/2. Okay, so it says to perform the indicated operation, and it says to state the domain, which I will tell you what the domains are as much as I possibly can, but I'm really not that worried about it. You know, honestly, let's just skip domains, okay? Ignore the part about the domains. Okay, it just wants to know what the x values that you can put in are, but for the sake of right now, just don't worry about that. I'd rather spend more time on that just next year when we hit domain and stuff. Okay, so let's look at something like number 4. Okay, so this says g of x plus f of x. So what they want us to do is they want us to add f of x and g of x together. So what that looks like is I'm going to write down the values for f of x, or sorry, g of x is first. I'm going to do that one first, though it doesn't really matter because I'm adding 5x to the 1/3 plus 4x to the 1/2. Okay, and then I'm adding on the f of x part plus, and since it's plus, I can just copy things down. Okay, now notice this is -3 here, so I do need to just kind of make note of that. -3x to the 1/3 plus 4x to the 1/2. Okay, so now I can combine like terms. I have a 5x to the 1/3 and a -3x to the 1/3. Both x's are raised to the same thing. So 5 minus 3 is 2, x to the 1/3. 4x to the 1/2 and 4x to the 1/2 gives me, add them together, 8x to the 1/2. Okay, and as far as, just if you're curious, okay, the domain would be anything except for negative real numbers. So essentially, if we were to write the domain, okay, like I said, you're not responsible for this, but I do want you to go ahead and just kind of see it. Okay, the domain, we write this as it's all real numbers, okay, minus the negative real numbers. Okay, so it's all real numbers minus the negative real numbers is the domain for this because we can't take the square root of a negative number. Okay, but anything else we can take the square root of. Like I said, you're not responsible for this, just so that you see it. Let's do 8, just because I want you to see this example. So we have g of x minus f of x. Okay, so notice that this negative sign, that's very critical that we keep everything with our signs correct. Okay, so g of x, again, we write down 5x to the 1/3 plus 4x to the 1/2 minus, okay, so make sure you do that. And then I would bracket off the rest of this stuff right now to make sure we pay attention to our signs. Okay, so negative 3x to the 1/3 plus 4x to the 1/2. Now, when I'm dealing with like terms here, I have 5x to the 1/3. I have minus a negative 3x, which means I'm adding. So 5 plus 3 is 8, so 8x to the 1/3. And then next I have 4x to the 1/2 minus 4x to the 1/2, which is just 0. So this here is my answer for that one. Okay? Now, you're looking at this, maybe you're wanting to know really quick what the domain is. And technically speaking, we could say it's all real numbers because it really doesn't matter if they're negative or not when you're taking the cube root of something. But for the sake of following the book, we'll just say all real numbers minus the negative real numbers. Okay. All right. So that's that section. Okay, moving down to the 12 through 19. These ones are multiplying and dividing. So with these ones, we're told to let f of x be equal to 4x to the 2/3 and g of x is equal to 5x to the 1/2. Okay, so with these problems, we have stuff like Let's go with 14. So with 14, we have f of x times f of x. Okay, and so essentially you just now are multiplying f of x times each other, or squaring f of x if you want to think about it that way. So f of x is 4x to the 2/3 times 4x to the 2/3. So now 4 times 4, well, that's 16. X times x, which is going to be x, and then I'm adding their exponents together. Okay, remember, when I'm multiplying numbers, you add their exponents, so that's going to be 4/3 there for that one. So 16x to the 4/3, and in this case, okay, it does still ask for the domain, but again, you're not responsible for that on this one, on these type either. Okay, the domain for these would in fact be all real numbers. Okay. Let me do a division one real quick. Let's do 16. So 16 f of x over g of x is equal to, well, f of x, we're told, is 4x to the 2/3. Let's do it down here. 4x to the 2/3 over g of x is 5x to the 1/2. So 5x to the 1/2. Now, obviously here, I don't have the same exponents. Okay, they are different, but I can still go about them the same way as I normally do. So 4 divided by 5, well, that's not something that I know, so I can just leave that as 4/5. If I can get my pen to write. 4/5. Now, normally, okay, what happens is we subtract our exponents. Okay, we need to get them all at the same place. So I'm going to bring this 1/2 up to the top by subtracting it. So that's going to give me x to the 2/3 minus 1/2. Okay, so I need to get a common denominator, which is going to be 6. So this is going to be 4/5 x to the, now to change this one to 6, I have to multiply it by 2/2. So it's going to give me 4/6 minus, to get this one over 6, I need to multiply the whole thing by 3/3. So that's going to be 3/6, which then I can write my answer as 4/5 x to the 1/6. And let's see. Our domain is all positive real numbers. Okay, so all real numbers minus the negative real numbers. Okay, again. Oops, sorry about that. Okay, so that's that type. So the one other thing that we need to cover here out of this section is composition functions. Okay, and evaluating what that looks like exactly. Essentially, there's 2 sections that have this in them that are involved here. So 20 through 27, and then 28 through 35. So there's a slight difference here in those, but let's go back and get a couple little notes on this first, and then we'll jump back to some problems here. So if you want to take a break and do some of these problems, that might be a good time to do that. In terms of your homework, you have to do, basically, you're doing 3 through 37 every other odd. So I'll put that here in case you're at a point where you want to stop and do some problems. Okay, and I'll put it again at the end of the video as well. Alright, so composition functions. So with these, okay, they're kind of set up the same way, but essentially what we're doing now is we're composing a function of another function. So in those ones we were just adding, subtracting, multiplying, or dividing functions. Now we're actually going to compose them. Okay, and your book does a great job on page 430 of actually showing you a picture of kind of what this looks like. I'm not going to draw that picture since it's already there for you, but I will make the note. so that you have it. So, composition of functions. Okay, so the composition of a function g, composition of a function g with a function f is h of x equal to g of f of x. Okay, sometimes this will be written another way. Okay, sometimes you might see this written as g a little o f of x. Okay, that's another way you might see it written. Our book always writes it this way, so focus on this way for right now. Okay, the domain of H is the set of all x values such that, so the ST is such that x is in the domain of f and f of x is in the domain of g. If that's confusing, don't stress about it. We're not worrying about domain with these ones. And again, your book has some good examples there on page 430 for you of that type, but I'm going to go through and do some homework problems for you. So, for 20 through 27, okay, we're told to let f of x equal 3x plus 2, g of x equal negative x squared, and h of x to be equal to x minus 2 over 5. And then it says to perform the indicated, or find the indicated value. Okay, so with these ones it's a little different because they're giving you an x value. So let's step back just for a second before I do these and look at what we're kind of talking about here, what's actually going on. Okay, so if you remember back to when we did substitution, okay, you'd be given a problem like 7x squared plus 3x minus 4, get a marker that works a little better. And then you were told that x is equal to 3, and they wanted to know what that was. Well, we did it by substitution where you just plugged in x is equal to 3, and we found a value for whatever that was. Okay, so essentially we're doing the same thing here, but we're doing it with functions. Okay, so when we did this, what we would have actually had this written as, this would have said f of x is equal to this whole function here, and then we were told that x is equal to 3. So when we solved it, the way we should have written it, and I don't remember if we did, but we should have written it as f of 3, that means we're plugging 3 in for x, is equal to, so now anywhere I see x, I put a 3. So 7 times 3 squared plus 3 times 3 minus 4. And then that would have been, let's see, 9 times 7 is 63. If I happen to do some math wrong, no, you don't get cookie points. I'm just kidding. If we come back to school, I might get you some cookies. Plus 9 minus 4. And let's see, that ends up being 68, I think. We'll see. Okay, so that ends up being 68. So essentially, that's what we did. But now we're doing that with functions. Okay, so basically, if I have this g of f of x here, wherever I see an x in g of x, I'm putting my f of x function. Okay, so let's jump back and actually look at these problems now, given this information up here. So, something like, start with an easy one, start with 20. So something like 20. f of g of negative 3. Okay, so with these ones, you always work from the inside out. Okay, so with composition functions, oh, that marker's not working properly. With composition functions, we always work from the inside out. Okay, that being said, here, if I can find the marker I want. Okay, g of x is negative x squared. Okay, and with g of x, they want us to plug in negative 3. So negative 3 is going in for x in g of x. So g of negative 3 is, so this is going to be negative and then negative 3 squared. Okay, and this is really important to pay attention to your signs here and why I'm using parentheses. Okay, because I'm told that g of x is negative x squared, but I want to plug in negative 3, so it's negative, parentheses, negative 3 squared. Okay, so this is, well, the negative 3 squared becomes positive 9, but I still have this negative out here. Oops, sorry, that just like delayed for a second. But there's still this negative out here, so it's going to be negative 9 now. And now I have that value, so I have g of negative 3. So now I'm going to go in and I'm going to say f of negative 9. So f of negative 9 is equal to, well, f of negative 9 is going to be, I'm plugging in 9 anywhere negative 9 anywhere I see x. So 3 times negative 9 plus 2. Book decided it wanted to fall. Okay, 3 times negative 9 is negative 27, plus 2 is negative 25, and that is the answer for that one. Okay, so these do take some getting used to when doing these. We have a couple more to do. Let's see, let's get one that's a little bit harder. Let's go to 26. Okay, 26 is about as hard as it can get with this type. 26, h of negative 4. So the beauty of this one is because we're plugging values in, I'm not going to end up with a fraction on top of a fraction, which is what would happen if it did not have this value here to plug in. So remember, start from the inside, work our way out. So h of negative 4, well, h of x is x minus 2 over 5. So h of negative 4 is equal to, well, negative 4 minus 2 all over 5, which is negative 6 over 5. So now I want to know what h of negative 6 over 5 is. So now I plug this in to here, which gives me negative 6 over 5 minus 2 all over 5. Okay? Well, I got to get a common denominator on the top. So I need to get this 2 over 5, or 2 over a 5. So I still have negative 6 over 5 minus, I have to multiply by 5 over 5, so that's 10 over 5, all over 5 still. Okay, so this is just dealing with fractions. Negative 6 minus 10 over 5 is negative 16 over 5, and that's still all over 5. And I think it was in this class that we spent a lot of time with what this actually means. If I have a fraction divided by a number, it's the same thing as multiplying by 1 over whatever the denominator is. So I'm going to come down here, negative 16 over 5 times 1 over 5, okay, is equal to negative 16 over 25. And that is my answer. Okay, so I know we don't like fractions. To be honest with you, I don't either, but that's what we have to do here. Okay, so now the very last type that we have to do is doing this without being given a value to be plugged into it. So what does that look like? Well, we're told here for these ones to let f of x be equal to 3x to the negative 1. Now notice, this is to the negative 1. G of x is 2x minus 7, and h of x is equal to x plus 4 over 3. Let's start with a slightly easier one. Let's see. Let's go with 28. All right, 28, we're wanting f of g of x. Okay, so basically in this one, since I'm not given a number, I'm just taking this and plugging g of x into f. So anywhere I see an x in the function f, I'm plugging in g of x. So what does that mean? Well, I have 3 times, now g of x is 2x minus 7, and then f of x, the x is being raised to the negative 1, so I have to raise that to the negative 1. We don't like negative exponents. So, that being said, we would rewrite this as 3 over 2x minus 7. And that would be our answer there for that one. Okay? And then one more example, and then I'll write the homework again for you just in case you didn't write it down earlier. 32. So 32 is h of g of x. Alright, so in this one, anywhere I see an x in h of x, I'm going to plug in the function g of x. So, h of x is x plus 4 over 3. So x is really this g of x value, so 2x minus 7. And I'm going to keep it in parentheses, okay, because I need to keep up with my signs and everything at the moment. So 2x minus 7 plus 4 all over 3. So now I have no more values with x, so I just need to rewrite 2x. Now, negative 7 plus 4 is negative 3, so minus 3 all over 3. And that's that. Alright, so just in case you didn't write it down before, reminder, your homework is 3 through 37, every other odd. Okay, and in case you didn't see my email, the best way to get in contact with me if you have questions is to shoot me a text on that Google number. I know this is a lot of material, so spend a couple days with it. You only have 2 sections this week. Let me know if you have questions or anything, and I hope everyone is staying safe and also getting a little bit of time to relax.